Hello, this is a little video about the pajamas button migration work that I've been doing. I'm going to talk about what it is, what I've done, things that have worked, tools that I've used, what's not worked. Yeah. So the goal is to migrate 560 buttons. These are findings from the Pajamas Adoption Scanner. And it turns out we can write buttons in loads of different ways, but a significant portion of them are written in a particular way, and that is links that look like buttons. And so those were a good candidate for sort of a code mod to migrate en masse. So that led me to my first MR, which essentially does this. It takes link2s that look like this, and replaces them with link button 2s calls which look like this. And this is a new helper that this MR added, and this just delegates to the pajamas button component, Rails view component. And as you can see, there's no need to pass classes anymore. And it now has new options that correspond to pajamas button component options like variant, category, block, and so on. And you can still pass, so you can still pass lots of other options. So like method still works. You can still pass additional classes if necessary, IDs, here's size and icon working, and so on. Here's a quick look at the helper itself. So you can see it just delegates directly to pajamas button component. So quick note on why I did it this way instead of migrating these directly to pajamas button component. Well, it's just an easier transformation. You know, from this to this is quite nice. It actually ends up with less code as well, whereas pajamas button component is quite verbose. Yeah, so that's why I went with this. It was just it was less work. So that's the first MR. So how did I go about it? Well, I first started looking into using semgrep for this, because semgrep does have an autofix functionality. Let me just try and find the documentation for this. Yes, so it does provide an autofix where you'll have a pattern like this, and then you can autofix it with this. So I started looking into that because the Pajamas Adoption Scanner already uses semgrep for its findings. So let me just show you what I had there. So this is what I started looking into. I'd look for a pattern like this. Link2, which has some stuff and then mentions GL button somewhere in a class list. And I was trying to do the very simplest thing of just rewriting the method call to this. And that worked, but there's other transformations I need to do, like remove GL button, replace button confirm with variant confirm, and so on. And basically what semgrep provides in terms of autofixing is quite limited. And that's for two reasons. One, we've got to use a generic language parser in semgrep because we are parsing HAML here. And HAML is not a supported language of semgrep. So you've got to use the generic parser. And that really limits the power of the pattern matching and auto fixing. So for instance, I might want to do something like class like this, where and then I could rewrite that to something like link button 2 and then I don't know, variant confirm. That's not a very good example, but what my point is, I need to rewrite the string inside this class declaration. And without a proper language parser, I don't think semgrep can do this. It can't manipulate a string. In any case, I'd probably want to make these meta variables, something like this, and this, so that I could use them in the rewrite, something like this. You know, and so on. But I just couldn't get it working. It then occurred to me it would be possible to do this in sort of multiple stages, sort of do first rewrite the link to link button to, and then have another whole rule that migrates, say, which updates the classes list and then adds options like this and do it bit by bit. But semgrep doesn't allow for sort of a pipeline of transformations. It's a sort of a one-shot thing. So I would have had to have written some wrapper script that ran semgrep multiple times. But that seemed clunky and inefficient. And ultimately, semgrep didn't seem like the right tool for the job. So that led me to Combi. And Combi is designed, let me just pull that up. Combi is designed for, and it's a very similar tool in a way. It's for searching and changing code. But it is fundamentally general by default. It has parsers in some sense, but they are really just options against the parser. So the key way Combi works is it parses on the assumption that there's some underlying structure to your code, that there are balanced brackets, balanced braces, balanced quotes. And that gets you a surprisingly long way. And because what I was trying to do was Ruby embedded in Haml, the Haml part didn't really matter. Combi is actually pretty good with parsing Ruby, so it worked out quite well in this case. The other benefit of Combi is that it does allow for a sort of pipeline of transformations, which is exactly what I needed. So what does that look like? Well, let me pull that up. So here is a configuration file for Combi. It's called button.toml. And each one of these is a transformation rule. And when I run Combi with this configuration file over the GitLab codebase, it runs each one of these rules or transformations in alphabetical order. That's why they have these funny names. Right. So just to give you a taste of what that looks like. So in this example, I want to rewrite fail unless equal, and then the first argument, second argument to assert equal. I've even swapped the order of the arguments there. Let's pick that back. Notice how this matching works, even though there are parentheses here, and there's a parentheses inside the string here, and that still works. And I can even unbalance these, and it still kind of, it still works. So I'm not in that case, but that's because that's not actually, yeah, that makes sense. This doesn't, vice versa. And you can also, so this is the matcher, and this is the rewrite. And you can also pass sort of conditions on when to run this match and rewrite. And that looks like this. So my very first rule here is it's normalizing class spaces and quotes. So actually that's not even, it's just normalizing quotes, ignore the spaces bit. So here we're matching link to calls, which have a class attribute, and they're double quoted, and I'm basing double quotes of single quotes. And there has to be a block as well here. And this is only running when the classes, so this is called a hole in Combi jargon. So run this when the class is whole. If it has button large inside the class as whole, then don't run it. If it has GL button, then do run it. In any other case, don't run it. So what this effectively does is normalizes quotes, but only when there's GL button in the classes list of a link to call. The next one, for instance, normalizes call syntax. So in Ruby, you can call with parentheses, or you can leave out parentheses, and this just normalizes to the much more common case in Haml where we don't use parentheses. And this only runs when GL button is in the classes list as well. So writing these rules, these transformations can get quite messy because you've sort of got to form this pipeline. So what I did is I wrote a little test harness to help me do this. And this effectively, how this test harness works is that I have this source file, which is just a load of examples that I've taken from the code base or just made up myself. And I've also got an expected result for this file. So this is handwritten how I would like the previous file to be transformed into this file. So the test script takes the button.haml file, runs the transformation rules on it, and then diffs the result with the expected result, and shows a diff if there is a problem. So let me just show you what that looks like. So here it is. This is basically a watch on the combi file tree. Clear the screen and then run the test. So if I write here, we get a pass, which is great. Let's remove one of the rules just to give you a sense of what will happen. So one of my last rules to run is something that fixes some key value spacing. So where I have a key, a colon, no space, and then a single quoted value, and then it puts a space between the two. So I'm just going to comment that out and see what that does on the result. And you can see that the space has been deleted there, space has been deleted there. Yeah. And so this harness is really useful as sort of test-driven development, essentially. It also makes sure I don't create regressions, which is super easy to do when you're writing rules like this. So just wanted to talk about some of the interesting transformations I've had to do to achieve this. This one transforms the class list into sort of a space-separated list of strings to this more normalized format where each class is surrounded by a vertical bar. So that means where you'd normally have classes like this, I want that to be like this. Now, why is that? Like that. So the problem with this format is that later transformation rules, I want to delete, say, a particular class and replace it with some options. Now, in this case, if I wanted to delete the foo class, I might need some checks to make sure that I delete the white space after and the white space before, but that will change depending on where in the class list foo is. A better example of that is if I want to delete something like button confirm. There are some classes which look very similar. So there's button confirm, but there's also button confirm secondary. So if I want to delete this class, I need to make sure that I haven't got this class. So I could either check for button confirm followed by a space, but that won't catch classes that are at the end of the class list. Using this format, it ensures that if I delete vertical bar, my class, and then another vertical bar, it'll work no matter where in the class list that class sits. So that's one thing I had to do. So this rule, as you can see, it adds a vertical bar at the beginning end of the class lists, runs it on certain conditions, which are common. You see this repeated in various transformation rules. But then there's this other additional thing you can do where you rewrite a whole. So rewrite classes, and I'm replacing all white spaces with double quotes. And this is a greedy match. So multiple white space becomes 2 bars. So let me just delete that and show you what that looks like. So you'll see, well, basically none of the transformations have worked. So that is quite a key rewrite rule that I've got there, because all of these rules rely on it. So here you can see I'm capturing before classes, which can be empty, and then button confirms secondary, and then after classes, and then I'm just concatenating the before and after, which again is safe to do thanks to this pipe transformation, and then adding the necessary changes to the rest of the call. And these are all quite similar to the rest here. What's next most interesting? So this one gets rid of redundant classes. So it actually doesn't rewrite. The rewrite rule is exactly the same as the match rule. So nothing changes there. I'm just changing the class as whole. And I'm just deleting classes that no longer serve any purpose, either because they're default, or I've already dealt with them. In fact, all of these, I think they're all just the defaults, although this one can just be removed in any case. What else is interesting? So this is quite interesting. Here, I've captured an indent hole, and you'll notice there's a space at the beginning. This basically says capture the white space up to this equals sign and call it indent, and that allows you to make a rewrite rule which goes over more than one line and keep the existing indentation. So I'm saying keep the existing indentation and then add 2 additional spaces. And that's a sort of necessary quirk that you have to do in Combi when you're doing multi-line rewrites. What else? And so this is also something quite interesting. I'm capturing an icon hole within a string, and then I can recreate the string in the rewrite rule here. Very similarly, I can capture an entire string argument and just pass it along in the call. Here I'm capturing the name of the get text call, which could be underscore or s underscore. So all of that is kind of just additional rules which capture additional cases. And then finally, at the end, I want to undo some of the transformations I've done. So this one undoes the pipe or vertical bar normalization of classes and replaces double bars with spaces. So if I undo this, if I comment this out, you can see the result. We've still got this sort of pipe format left. So that's working as intended. And I'm also removing any superfluous white space. I'm not sure that this is strictly necessary anymore. That one isn't. That one isn't either. Was there? I'm sure there was something why they were still there. Yeah, so interestingly, I'm not entirely sure what's going on here. If I remove this one, it passes. If I just remove the next one, it also passes. But if I remove both, it doesn't pass, which is odd. And it's because we've got a class with just a single space. I'm not sure why that's there. So those two together just sort out that. I think this is from an earlier iteration before I was doing the vertical pipe handling for transformation. This one just removes the empty class case. You can see without that, we'd just be left with a class list with which is just an empty string, because we've removed all the redundant classes like you can't see them in the diff, but we've removed button, GL button, and so on, and that's just left an empty string. And so we want to remove that. And then finally, this last one you've already seen, it just fixes some weird key value spacing, which for some reason needs to be done. So that's the sort of tooling that I've written to help develop this set of transformations. The test script, as you can see, is pretty small. It basically, yeah, like I said, copies the source to the actual, then runs the combi on the actual, and then runs a diff on the expected versus the actual, and then prints out a failed to pass. I wrote another little script which helps to see how these changes I'm making to these rules affect the GitLab code base. And that's called compare commits. So the basic idea of this script is, let me just show you, compare commits. So this command will run the Pajamas adoption scanner combi rule set from 50 commits ago against some base commit of GitLab. And then it will run the current commit of Pajamas adoption scanner combi rule set against that same base commit of GitLab, and then print the diff of the result. It's quite a mouthful. So if I just run this, so you can see it's creating a button migration before branch on GitLab. It'll also create a button migration after branch here. And then when the script finishes, it cleans up and removes those temporary branch names. They're just there to help with the diffing. So you can see here, this is the start of the diff, the end of the diff. In 50 commits, running that particular rule set anyway, the only difference is we've got one line of difference, and there's a do block, which is removed. That seems to be the only difference here. But anyway, that script is really useful to verify that changes to my TOML file don't have unintended consequences that aren't sort of captured in my test suite. So that's, I think that about wraps it up. Although I do also have, so that was my first mass button migration. That was about 56 files changed and about, I think it was about 130 buttons migrated. I also created a second one that's still in review. It changes more files, but fewer buttons. And it captures something slightly different. My first one was focused on link button twos, which have a block. And this one is focused on ones which do not have block. But the rule set is very similar, although it's not exactly the same. And I just have a separate file called, very imaginatively, button2 TOML. And this is essentially a copy-paste version of the other TOML file, but with some changes and new tests. So I've got a button2 HAML, button2 expected HAML. But yeah, it works in largely the same way. See, I've even commented some stuff out. Yeah. So overall, I think this has been, successful. I think Combi's a really good tool for one-off rewrites, one-off transformations, which I think these button migrations are. I would not expect to do this on a regular basis. because writing these pipelined transforms is fiddly, but once you've written them, you can just rerun them against the code base, which is great, but they are fiddly, so I wouldn't recommend it. So actually, it is worth talking about this second one. It does something slightly differently. One of the things I found I need to do in the case of link2s without a block is make sure I ignore the ones that I need to ignore. So this is essentially a deny list almost. So I'm matching link2s and then capturing something that goes up to and including the next new line. And then I'm marking them with ignore. I'm literally changing the text to say link to ignore and preserving everything else. And I want this to run when there is no GL button present in this large match. If there's no GL button in the entire argument set to link2, then ignore them. So this is links which are just regular links that don't look like buttons. That seemed like a necessary first step. And I also in this, so I'm also doing similar things with changing full syntax and quoting here. Again, something I had to do something slightly differently in this case. I'm now marking, in this rule, I'm marking link2 calls as things that we want to migrate. Now, why have I written it like this? Link2, when called with a block, the first argument is actually the URL, and everything shifts along left one. But without a block, the first argument is the content and the second argument is the URL, and any third argument is actually going to be a keyword argument or a literal hash of options. So with that realization, I figured out how to target these in particular. So what's going on here? I'm saying match link2s where there's a first argument, a comma, and a second argument, followed by another comma, and rewrite and mark them as to do when the second argument, if there's something which goes one or more word characters at the beginning, followed by a colon, followed by space, which is basically a keyword argument, then do not apply this rule, as in do not mark them to do. There are some cases, so this is saying if it starts with a single quote and then basically some string followed by a colon, that is also another way to pass a keyword argument, a named keyword argument that isn't sort of an identifier. Also don't do it. Similar with double quotes. In any other case, do it. Yes, I'm now wondering why I don't have a check that GL button is there. I'm not sure why I haven't done that. There's probably something in the rest that sorts that out. Like I said, it's a bit messy, and I you know, it's a write once kind of tool, I think. Anyway, at the end, I have to unmark my ignores and finally rewrite my to-dos as link button 2. And I kind of don't even need to worry about all the rest, so I just do the first argument. So I think that about wraps it up. I highly recommend taking a look at Combi if you want to do sort of one-off transformations across the code base. It's surprisingly powerful, and the documentation is well worth reading. There's also a talk that the author gave at Strangeloop, which actually made me appreciate just how powerful it actually is, because before I watched it, I was a bit skeptical. So I'll include that and lots of other links in the description to this video. Yeah, and that about wraps it up. So with the first migration and the second migration, that totals about 250 odd buttons migrated, which is good, which certainly moves the needle on this KR. That about wraps it up. Thanks for watching.